In the previous lecture, we talked about some examples of Fourier series. We now have some more examples. In this example, it says that show that the Fourier series of this function where x between minus half of pi to a half of pi and f of x should be f of x plus pi is given by this. That means we should find the Fourier series for that function, and the result, the final result must be this. It says show that the Fourier series for that function is this. Okay, here in the first step, we should determine t and l. T is the period. The period here is pi, because we say if f of x equals f of x plus t, then the period is t. So here t is pi because it's pi, and L is the upper limit of the it's upper limit of the interval. The interval is from negative L to L. It's from negative L to L. So L here is pi over 2. These are T and L. Now we find, we draw the graph of the function. Here we have the absolute value of sine x. We have the absolute value of sine x. You say this is x, this is y. And the graph, we should draw the graph from minus pi over 2 to pi over 2. At 0, sine is 0. We have sine x in an absolute value. Sine 0 is 0. And sine pi over 2 is 1. Sine minus pi over 2 is minus 1. In absolute value, it becomes 1. So this is the graph. This is the graph for the function. Okay, it's an absolute value for sine. Every time you get a positive value, and an absolute value is a V shape.
And you have any execution.
Yeah, yes, it's similar to x. Yeah, it's the same as x. Yeah. We now have we check whether f is odd, even, or neither functions. We say f of x equals the absolute value of sine x. To check whether the function is odd or even, we are going to find f of minus x. We are going to find f of minus x. You find f of minus x. If it equals to f of x, then it's even. It's even. If it equals to minus f of x, it's odd. If none, it's neither. Neither of them. Okay? If it's none of them, it means the function is neither even nor odd. Here we find f of minus x. F of minus x is the absolute value of sine minus x. And sine minus x is minus sine x. And this equals to the absolute value of sine x. And this equals to f of x. As you see, f of minus x equals f of x. That means the function is an even function. So the function is even. Okay. For even functions, we just find a naught and a n. For even functions, we just find a naught and a n. But for odd functions, we find only bn. Here, to calculate the Fourier series for f of x, we say since the function is f of x is even, then bn is 0. bn is 0. And the Fourier series formula becomes f of x equals a naught over 2 plus the sum n from 1 to infinity, n from 1 to infinity, For an cosine and pi x over L. We find only this. Okay? Let's find a naught and an. Here, we should find a naught and n. We have given L. L is pi over 2. We found in the first step. L is pi over 2. So you just need to find a naught and a n. And then we replace here. We get the Fourier series for the function. We find a naught. A naught equals 1 over L. Here. Sorry. Okay, we don't need it. We say a naught equals 1 over L, the integration from minus L to L for f of x dx. And this equals to, since the function is even, we can take only the upper half of the interval. It's from negative L to L. We take from 0 to L and we multiply it by 2. We multiply it by 2 and we get 1 over L integration from 0 to L multiplied by 2. Okay? Say 2 over L. We multiply it by 2 and we take the half of the range.
So why you multiply by 2?
Because it is from minus L, as you see, it's minus L. This is 0, this is L. From here to here,
You calculate the
yeah, we take only a half of the interval. So we must multiply it by 2. Since the function is even. If it's not even, we cannot do that. We cannot do that. And now we have f of x dx. And this equals to 2 over L is pi over 2. Pi over 2. Integration from 0 to pi over 2. For f of x is the absolute value of sine x. So the absolute value of sine x is sine x when x is greater than 0, less than pi over 2. Okay? And equals to minus sine x, f is from negative pi over 2 to x to 0. And here we have from 0 to pi over 2. So we just take sine. We don't take absolute value of sine. Okay? We take only sine function. We don't take the negative part because our interval is from 0, as you see, it's from 0 to pi over 2. So we must just take only sine x. That's why we don't take the absolute value. Okay? Dx. Now we take that integration. This not. So this equals to the integration of sine is negative cosine. It's negative cosine. We get 4 over pi. This becomes 4 over pi. 2 over pi over 2 is 4 over pi. The integration of sine is minus cosine x from 0 to pi over 2. If we replace cosine by pi over 2, we get 0 because cosine pi over 2 is 0. And when we replace x by 0, so we get cosine 0, it's 1. First, we replace by pi over 2, we get 4 over pi minus cosine pi over 2 minus cosine 0. This negative sign is for the rule. Okay? This one is for the rule. This equals to 4 over pi. This part is 0 because cosine pi over 2 is 0. Then cosine 0 is 1. And you have minus times minus is positive. This equals to 4 over pi. This is a naught. So a naught is pi over 4. So a naught is pi over 4. We found a naught. Now we should find a n also. We should find a n. To find a n, we say a n equals 1 over L integration from minus L to L for f of x times cosine and pi x over L dx. Yeah, we take only the positive part of the integral of the interval. It's from 0 to pi over 2. We take from 0 to pi over 2, and L is pi over 2. You get 2 over pi over 2. It's the same as the previous one. That's why I'm not going to write down step by step. It's integration from 0 to pi over 2. F of x is sine. We just take the sine function. We don't take the absolute value because we took from 0 to pi over 2. And from 0 to pi over 2, we have only sine times cosine and pi x over L. We replace L by pi over 2. Cosine and pi x over L. L is pi over 2. These two are cancelled out, and we get 2nx. Is it? We get 2nx. If these two pi are cancelled out, we get 2nx dx. It's n pi x over L. L is pi over 2. When we replace it by pi over 2, pi are cancelled out. Then we get cosine 2nx dx. Now we have this integration. We have sine was multiplied by cosine. Okay. We can use the trigonometric identities to write down this trigonometric function. We say sine A times cosine B equals sine A plus B plus sine A minus B dividing by 2. That's trigonometric identity. That's rule. Say sine A times cosine B is sine A sine B is sine A plus B plus sine A minus B divided by 2. Okay. Now we have sine 1x sine 1x cosine 2nx dx. This equals to, here it becomes 4 over pi. This becomes 4 over pi. Integration from 0 to pi over 2. Sine x cosine 2nx, it becomes sine 1 plus 2nx. We add them, sine x plus 2nx. We take x as the common, we get 1 plus 2nx. Plus sine 1 minus 2nx, all dividing by 2 dx. Here we cannot find the integration. We should rewrite down it. Then finding its integration, it's easy now to find the integration. Here we took this 2 out, and it will be cancelled out with this 4. We get 2 over pi. Okay, we get 2 over pi. 2 over pi, integration from 0 to pi over 2. We have sine 1 plus 2nx plus sine 1 minus 2nx dx. We have these two terms. We have these two terms. In both, we have sine. Integration of sine is cosine, is negative cosine. Integration of sine is negative cosine. This equals to 2 over pi. Integration of sine is negative cosine. But here, we must have the derivative for the angle. Derivative of the angle is 1 plus 2n. Here, it is 1 plus 2n x. Derivative of this with respect to x is 1 plus 2n. We must have 1 plus 2n. So we multiply it by 1 plus 2n and dividing by 1 plus 2n. And we get 1 over 1 plus 2n times minus cosine 1 plus 2n x. We get that. This is the integration for the first part. And for the second part is the same. We must have derivative of the angle, which is 1 minus 2n plus 1 over 1 minus 2n times negative cosine 1 minus 2nx. Okay. It's from 0 to pi over 2. From 0 to pi over 2. Now, let's take these negative signs to out. Here we get, if we take negative sign from this and that one, we take it as the common, the negative sign, and we get minus 2 over pi times 1 over 1 plus 2n cosine 1 plus 2nx plus 1 over 1 minus 2n cosine 1 minus 2nx from 0 to pi over 2. Now we replace x by pi over 2, then by 0. We replace by pi over 2, then by 0. But here, you should know that cosine at this line, cosine of the angles on this line is 0. Okay? And those angles are pi over 2 plus minus n pi. It's pi over 2 plus minus n pi. Okay? Let's first replace x by pi over 2. So cosine of pi over 2 plus minus n pi is 0. You say it equals to 2 over pi. If we replace x by pi over 2, we get 1 over 1 plus 2n cosine 1 plus 2n times pi over 2. This is 0. Because here we get pi over 2 plus n pi. Yeah. Yes. It's on the vertical line, vertical axis, plus 1 over 1 minus 2n times cosine 1 minus 2n times pi over 2. It's the same. This is 0 also. This is for pi over 2. Now we replace x by 0 minus. If we replace x by 0, here we get cosine 0. Cosine 0 is 1. So we get 1 over 1 plus 2n. Is it? And here, if we replace x by 0, we get cosine 0. Cosine 0 is 1. We get plus 1 over 1 minus 2n. That's it. Now, we say this is 0 and this is 0. So we get minus 2 over pi. Minus 2 over pi. And here we get minus 1 over 1 plus 2 plus 1 over 1 minus 2. This minus also. 2n. Here we are going to find the common denominator. We are going to find the common denominator here. The common is 1 minus 2n times 1 plus 2n. And we get minus 2 over pi times. Let's take that negative sign also to out of the, yeah, this becomes positive, this becomes positive, and this becomes positive, okay? If we take a negative sign as the common here, this negative. And if we take a negative sign, it becomes positive, okay? So the common denominator here is 1 plus 2n and 1 minus 2n. And we multiply this to there and this to there. We get 1 minus 2n plus 1 plus 2n. These two are cancelled and we get only 2. This equals to 2 over pi times 2 over. Here we have 1 minus 2n, 1 plus 2n. We get 1 plus 4n, 1 minus 4n squared. It's difference between squares. It's minus. It's difference between difference of squares. And we can take this out. It equals to 4 over pi times 1 over 1 minus 4n squared. This is an. Okay, this is an. Where's it? Okay, this an. Now we put an and a naught into this formula. This formula. We are gonna put a naught and an here. F of x is a naught over 2. A naught over 2. F of x equals a naught over 2 plus the sum from n equals to 1 to infinity for an times cosine n pi x over L. This equals a naught. We found a naught before, which is pi over 4. Pi over 4 over 2 plus the sum n equals 1 to infinity. For an is 4 over pi times 1 over 1 minus 4n squared times cosine n pi x over L. L here is pi over 2. These two are cancelled and you get cosine 2nx. You get cosine 2nx. And you can take this 4 over pi out of the summation. It equals. And these two are cancelled out. We get pi over 2 plus 4 over pi summation n equals to from 1 to infinity for 1 over 1 minus 4n squared cosine 2nx. This is f of x. This is the Fourier series which is required. Let's compare. Let's compare. This is given. Here it's 2 over pi minus 4 over pi. So it's pi over 4. Yeah. Sorry, a naught is 4 over pi, not pi over 4. I did a mistake here. This is 4 over pi, as you see in the previous step. No, I have لهنا أو تم around here. This is 4 over pi. These two are cancelled out. You get 2 over pi. Okay? No, yeah, it should be 2 over pi, not pi. And minus 4 over pi, the sum of 4n squared minus 1. But we got 1 minus 4n squared. If we take a negative sign there, we get the same result. Here, if we take a negative sign here, it's 1 minus 4n squared. If we take a negative sign, it becomes 4n squared minus 1. And we take the negative sign out of the summation, it becomes 2 over pi plus, minus 4 over pi, the sum, n equals 1 to infinity, for 1 over 4n squared minus 1. If we take a negative sign here, it becomes 4n squared minus 1. And we take the negative sign out of the summation. We get minus 4 over n over pi times cosine 2nx. This is the required. This is the Fourier series for absolute value of sine. Sorry. Which one? Yeah, it's equals to 1 to infinity. This is final result. This is, as you see, if you compare this result that you get with the one which is given there, it says show that it equals to this. We got the same result. Okay. We now have another example. It says find the Fourier series of this function, for this function, where f of x plus 2 pi equals f of x. Here, in the first step, we are going to find the period and the upper bounds of the interval. I mean L. We find L. T is 2 pi. So capital T is 2 pi. It's given there. And L is pi. Since that's from negative pi to pi, that means it's from negative L to L. So L is pi. Now it says draw the graph. As a piecewise function, we are going to draw each part in its interval. F of x is x, where x is from negative pi to 0, and equals to 0 for x from 0 to pi. Let's draw the graph. This is x, this is y, or f of x. We draw the graph from minus pi to pi. Okay, we say f of x equals x for x is from negative pi to 0. That means it's negative pi. This is for this part. This is the graph of this part. If we give negative pi to x, we get negative pi. If we give 0 to x, we get 0. So we join them, we get the graph. And then it says it equals to 0 for x from 0 to pi. From 0 to pi, this equals to 0. It's on the x-axis. This is the graph. This is the graph for that piecewise function. We draw each function in its interval. Now it says check whether f of x is either odd, even, or neither functions. Sorry, it's none of them. Yeah, it's none of them. Sorry. Yes, the function is neither even nor odd. So we say since sorry. Yes, from the graph you can see it's not symmetric to y-axis, and even it's not symmetric to the origin, as it's not symmetric to y and to the origin. That's why we say it's not odd, it's neither odd nor even. So since f of x, f of negative x doesn't equal to f of x, and f of minus x doesn't equal to minus f of x, thus the function is neither odd nor even. So we say if a function is neither odd nor even, we must find all a0, an, and bn. We must find them all. Okay, and the Fourier series here in this case, so f of x equals a0 over 2 plus the sum for n from 1 to infinity for an cosine n pi x over L plus bn sine n pi x over L. And here we must find a0, an, and bn, and plug into here to get the results. Let's find a0, an, and bn. That's it. Now to find a0 is 1 over L, the integration from minus L to L for f of x dx. But here f of x is two parts. It's two parts. It's two different functions. One of them is x and the other one is 0. For x is from negative pi to 0. Look, here we have these two different functions, x and 0. For x, we have this interval. So we take the integration from negative pi to 0 for x. But for 0, we take the integration from 0 to pi. That means from minus L to L, it becomes 1 over L, 1 over pi. L is pi. Integration from negative pi to 0 for x dx plus 1 over pi. Integration from 0 to pi for 0 dx. We have two different functions, which are x and 0. For each, we use its interval for the limits of integration. It equals to, this equals to 0, because integration of 0 is still 0. The defined integration is 0, but the undefined integration is a constant. This equals to 1 over pi. Integration of x is x squared from negative pi to 0. This equals to, if we replace by 0, we get 0. But if we are replaced by negative pi, we get pi squared over pi with pi. So this is a naught. A naught is pi. So it's minus pi. We get minus pi. Here we replace 1 over pi times 0 minus pi squared. We get 1 over pi times minus pi squared. This or this are cancelled and you get only minus pi. Okay? So A naught is minus pi. This is A naught. Then for finding an equals 1 over L, the integration from negative L to L for f of x times cosine n pi x over L, sorry, n pi x over L dx. This equals to, even for this one, it's two parts. One of them from negative pi to 0, and the other one from 0 to pi. This equals 1 over pi integration from from negative pi to 0. The function from negative pi to 0 is x. From negative pi to 0 is x. The function is x. X times cosine n pi x over L. L is pi. These two are cancelled, so you get nx dx plus 1 over pi integration from 0 to pi for 0 times cosine n x dx. This is 0. Okay, this is 0 because 0 times cosine is 0. Integration of the defined integration of 0 is still 0. This equals to 1 over pi, the integration of x cosine x. We use the short method, derivative and integration. That's x and cosine and x. Derivative of course of x is 1. Another derivative, it gets 0. Integration of cosine is sine, but here we have 1 over n sine. Then minus 1 over n squared cosine. It's sine nx, not sine x. Okay. Now we multiply these two, then negative, we multiply these two. We have x over n for sine nx plus. Here we have negative times negative is positive. We get 1 over n squared cosine nx. X is from 0, from negative pi to 0. X is from negative pi to 0. This equals to 0. It's from negative pi to 0. First, we replace x by 0, and then we replace by negative pi. This equals to 1 over pi. If we replace this by 0, we get 0 times sine 0. It is still 0. It's 0 plus cosine 0, 1 over n squared cosine 0. Then minus, we replace x by pi. we get pi over n sine minus n pi, okay, plus 1 over n squared cosine minus n pi. Okay, and this equals to this is 0, 1 over pi, and 1 over n squared times cosine 0. Cosine 0 is 1, so you get 1 over n squared. Then minus. Here, sine minus n pi is 0. Sine minus n pi is 0. Because it is on the horizontal axis, so it's 0. You get 0 plus cosine minus n pi is the same as sine n pi, cosine n pi, and cosine n pi is minus 1 to the power n. It's 1 when n is even, and it's negative 1 when n is odd. You get 1 over n squared times minus 1 to the power n. Now you simplify it more, we get 1 over pi times 1 over n squared minus 1 over n squared minus 1 to the power n. Okay, we now can take 1 over n squared as the common. We get 1 over n squared pi times 1 minus 1 to the power n. That's it. We took 1 over n squared as the common. We multiplied by 1 over pi, we get 1 over n squared pi, and in the bracket we get only 1 minus 1 times 1, negative 1 to the power n is negative 1 to the power n. We get this. This is an. Now we should find bn. For bn, we do the same. Bn equals 1 over L integration from minus L to L for f of x times sine n pi x over L. But here the function is 2 parts. It's a piecewise function, and we use the interval for each one. 1 over L is 1 over pi integration from negative pi to 0. F of x is x here times sine n pi x over pi is nx dx plus integration from 0 to pi for 0 times sine nx dx. This is 0. Okay, this is 0, and we only have this one of pi. Sorry, we only have this part. We find this integration. This equals to 1 over pi times, here we have, we use the short method for finding the integration. D I, this x is sine nx. We take derivatives till we get 0. Derivative of x is 1, another derivative is 0. And for sine nx, its integration is minus 1 over n cosine nx. Another integration is minus 1 over n squared sine nx. Okay, we get, we say it equals to 1 over pi times minus, this is a negative sign. Here you have a negative sign. We multiply these two, then minus, we multiply these two. We get minus 1 over n minus x over n, sorry, because x times minus 1 over n cosine nx is minus x over n cosine nx plus, here negative times negative is positive, so 1 over n squared sine nx from negative pi to 0. We first replace by 0. If you replace by 0, this becomes 0, and this also 0. Both become 0 because the first term here we have x times cosine nx. it becomes 0. And in the second term, we have sine 0. Sine 0 is 0. This equals to 1 over pi. 0 minus. We replace by negative pi. When we replace by negative pi, cosine nx becomes minus 1 to the power n. Minus 1 to the power n. And we replace this x by negative pi, we get pi here. We get pi over n times minus 1 to the power n. Then plus 1 over n squared sine n pi. Sine n pi is 0. Yeah, this becomes 0 when we replace x by pi. We get sine n pi. Sine n pi is 0 because it's on the horizontal axis. This equals to 1 over pi times pi over n minus pi over n times minus 1 to the power n. Yeah, these two are cancelled out. We get minus 1 over n. So it equals minus 1 over n times minus 1 to the power n. This is Bn. We now have A naught, An, and Bn. We just plug into the formula. F of x equals A naught over 2 plus the sum of n from 1 to infinity for An cosine nx plus Bn sine. Here I'm just going to write down nx because it's n pi x over l. L is pi, that's why these two are cancelled out and you get only nx. This equals to I naught is negative pi. It's negative pi over 2. Negative pi over 2 plus the sum of n from 1 to infinity. For An, we found An, which is 1 over n squared pi times 1 minus minus 1 to the power n times cosine nx plus Bn is minus 1 over n times minus 1 to the power n times sine nx. This is the Fourier series. We just find I know and Bn, then we plug into the formula. Yeah. Yes. Let's take a break. We now have the last section of this chapter, which is Fourier series of half-range expansions. Here in this section, we have given a half range of the expansion. We don't get the interval from negative L to L. We just get from 0 to L or from negative L to 0. We just get only the half of the range. It says here you have a question. It says, can you find a Fourier series expansion for a function defined over a finite interval? Here we say, as for now, we know a periodic function demands an infinite interval. Here for the periodic functions, we need to have infinite intervals. So the answer of this question is yes. But we need to convert the non-periodic function into periodic functions. So you must convert the non-periodic functions to periodic functions. Then we can do it. Here we have two types of half range Fourier series, which are Fourier cosine series and also Fourier sine series. If we are asked to find the Fourier cosine series, here we just need to A naught and An. Bn is 0 in this case. But for sine Fourier series, Fourier sine series, here we just find Bn. In this case, A naught and An is 0. But here, for half range, we say A naught is 2 over L from 0 to L f of x dx. This is the formula for finding A naught. And for An, we say it is 2 over L, the integration from 0 to L for f of x cosine x, cosine n pi x over L dx. Here we find the a naught and a n by using these two formulas. It's for Fourier cosine series. If we are asked to find Fourier cosine series, we just need to find a naught and a n by using these two formula, and then we plug into here to this formula. That would be the Fourier cosine series. And for Fourier sine series, it's in this form. This is the Fourier sine series. Here we have only Bn. We can get Bn by using this formula. We can get Bn by using this formula, and then we plug into the above formula to get the Fourier sine series. Now we have an example. It says find the half range for a series for this function. It says find the half range for a series for this function. The function is 1 minus x, where x is from 0 to 1. As you see, it's given from 0 to 1. So it's half range. It's half range. So here, as we are asked to find the half range for a series, if we are asked to find the half range for a series, we should find Fourier cosine and Fourier sine. We must find these both. If you are asked to find the half Fourier series, we must find both Fourier sine and Fourier cosine. First, for finding Fourier cosine, series, here we say, in this case, we find a naught and a n, as it's given above here. For Fourier cosine function, for Fourier cosine series, we should find a naught and a n. When do we find a naught and a n? If the function is even. If the function is even, then we can just find a naught and a n. So here we have given this function. We have given this function. We must convert this function to an even function. We must convert the function to an even function, because here we just find a naught and a n. In this case, the function must be an even function. To convert this to an even function, what we do? Here we have a note. It says an even function is symmetry about y-axis. First, let's draw the graph for f of x. We draw the graph for f of x. Then we find its symmetrical part to y-axis. Then from that symmetrical part, we can find the other part of the function. Here, let's first draw the graph for this function. The graph of this function is 1 minus x. If x to be 0, it's 1. If x to be 1, it's 0. 1, 1. This is the graph of the given function. Okay? If this function is an even function, so it must be symmetry to y-axis. So the other part of the graph must be like this. This is the symmetric part of that graph. So it must be like this. Then it is an even function. So what is the function for this part? What's the function for this part? We say we can get the function from this graph. The graph is starting from this point to that point. It's starting from this point to that point. We can use the equation of a line to get the equation. It's -1. Add -1 is 0. Add -1 is 0. And add 0 is 1. That means it is 1, sorry, x minus 1. It's x, sorry, plus 1. It's x plus 1. Look, if we replace x by -1, we get 0. And if we replace x by 0, we get 1. So the equation for this part is x plus 1. And this part is from -1 to 0. It's from -1 to 0. So f of x becomes 1 minus x for x to be less than 1 and greater than 0. And it's x plus 1 for x to be less than 0 and greater than -1. This is an even function. We first must construct the even function. From that function which is given, from this function, we draw its graph. Then we find its other part, which is symmetric to y-axis. Then from this part, we can get the other part of the equation. So it's a piecewise function, and this function is an even function. It is an even function. For even functions, we just find a naught and a n. We just find a naught and a n. Here, to find a naught, we say a naught is 2 over L integration from 0 to L for f of x dx. From 0 to L means from 0 to 1. L here is 1. L here is 1. It's from -1 to 1. That's from -1 to 1. So we just get 1 for L. We say it's 2 over 1 integration from 0 to 1 for f of x. F of x from 0 to 1, from 0 to 1, it's from 0 to 1. The function is 1 minus x. We just take that part. From 0 to 1, we have 1 minus x dx. This equals to 2. Integration of 1 minus x is x minus x squared over 2 from 0 to 1. And we replace x by 1 first, then by 0. If we replace by 1, we get 2, 1 minus 1 over 2, then minus 0. This equals to 1. It's 1. Here we get half in the bracket, multiplying by 2 is 1. A naught is 1. This is a naught. And then for finding an, to find an, you say an, let me check it. Oh, it's written down here, an. Let's find an here. An is 2 over L, integration from 0 to L for f of x times cosine and pi x over L dx. L here is 1. L is 1. And f of x from 0 to 1 is 1 minus x. An equals 2 over 1. Integration from 0 to 1. From 0 to 1, we have 1 minus x. The interval from 0 to 1 is for 1 minus x. 1 minus x times cosine and pi x over L. L is 1 dx. And this equals to 2, the integration from 0 to 1 for 1 minus x cosine and pi x dx. Here, we use the short method for finding this integration. We use the short method for finding this integration. It's multiplication of two functions. Yeah, d and I. It's 1 minus x. This is cosine and pi x. Derivative of 1 minus x is minus 1. Another derivative is 0. And integration of cosine is sine, but derivative of the angle is n pi. So it's 1 over n pi sine nx. Then under integration, we get minus 1 over n squared pi squared cosine and pi x. Okay, because the integration of sine is negative cosine, that's why we get this negative sign. We multiply these two, then we multiply these two, and then we add a negative sign to it. And the result is an is 2 times 1 minus x times 1 over n pi sine n pi x. Then negative times negative is positive, and here we have a negative sign also. It's minus 1 over n squared pi squared cosine n pi x from 0 to 1. We first replace x by 1, then we replace by 0. When we replace x by 1, this becomes 0 because the bracket is 0 because it's 1 minus x. If we replace x by 1, we get 0. And when we replace this here, if we replace x by 1, we get cosine n pi. And cosine n pi is minus 1 to the power n. Okay? We get 2 times. Here we get minus 1 over n squared pi squared times minus 1 to the power n. This is when we replace x by 1. And if you replace x by 0, this becomes 0. Why? Because here we have sine 0. Sine 0 is 0. And this becomes cosine 0 is 1. We get 1 over n squared pi squared minus 1 over n squared pi squared. And here you have this negative sign also. And this equals to. We can take minus 1 over n squared pi squared as the common. And you get, okay, first let's enter this one. And then we take 1 over n squared pi squared as the common. We get 2 times 1 over negative 1 of n squared pi squared times minus 1 to the power n plus 1 over n squared pi squared. And an equals. Here we take 1 over n squared pi squared as the common. We get 2 over n squared pi squared. 2 over n squared pi squared. Here we get minus 1 to the power n plus 1. This is an. Here we found a naught and an. We plug a naught and an into this formula. We get the results. We get the result. Let's write down it. We said a naught is 1. Is it? A naught is 1. So f of x is a naught over 2, which is 1 over 2, plus the sum n equals 1 to infinity. For an, which is 2 over n squared pi squared times minus 1 to the power n plus 1 times cosine n pi x over L is 1. This is the cosine Fourier series. This is the cosine Fourier series for that function. Now we have sine Fourier series. It's for next lecture. That's enough for today.